Alright guys, in this video we're going to be introducing the concept of a definite integral. And we're going to start by looking at a graph of a function and seeing how that connects with the Riemann sum idea. We did see a brief video prior to this where they made the connection between the two. And remember, you can kind of just think of the integral symbol as sort of an infinite amount of little rectangles, if you will, added up to create a Riemann sum approximation. The only difference is with an integral, this is actually the best approximation possible. It, like we said, is like an infinite amount of these little divisions. And we have seen integrals in the past. Back before Riemann sums, we saw integrals. However, they didn't have little numbers down here and up here. So these two numbers are what make our integrals definite. Before, we called them indefinite integrals or indefinite integration. This is going to be definite integrals. In future videos, we'll see how we're going to use what's called the fundamental theorem of calculus to solve a problem like this without a graph. But for today, we are going to look at graphs, and you will see problems like this on the AP test. So this is an important concept to understand. But let me go ahead and just give you a brief introduction, like what these numbers here mean. These two numbers are called the limits. We've got the upper limit and the lower limit. You can think of these limits as like an interval. So what this integral says as a whole, this integral states that basically it wants you to find the area under the curve from x equals -5 to x equals 9. So again, the integral is referring to area under a curve. That's what it means when you integrate something. You're finding the area under the curve, and these limits tell us where we want to start and where we're going to end. So if we look at this graph, we want to go to -5, it's right here, x value, and I'm going to just draw a line straight up because we don't want to cross that, and we want to end at 9, so down here. So what we're going to be tasked to do is to find the area under the curve from here, all this area, and this area, add it all together. We want to find that area under the curve. Don't worry about why we want to do that at this point. Just know that's what we're trying to do. So how we're going to accomplish this is we're going to divide up this integral. You're allowed to divide integrals into different subsections, if you will, so long as you don't miss any points in between. So what we're going to do is look for some natural places to divide it. And you'll see here, didn't mean to erase everything, here to here. So if we're starting here and ending here, what you're going to do is basically look to divide this into rectangles and triangles. Because those are two easy things that we know how to find the area of, right? Area of a rectangle is just, well, length times width. And area of a triangle, 1/2 base times height. So we know how to do these, and as it turns out, these graphs are all going to be these nice straight lines, which will divide really nicely into rectangles and triangles. Now that won't be the case if we have a more complex function, and that's what we're going to use the fundamental theorem of calculus for. But for now, let's stick with the basics and look for some natural places where this divides. So my first section is going to be right here. You can see if I were to just look at this section from -5 to -1, there's a nice, looks like a square here, which is a rectangle, right? So my first integral, I'm going to subdivide this. I'm going to start with -5 at my bottom one, but I'm going to end this one at -1. And then I'm going to write my f of x dx. Okay, and then I'm going to look for my next interval, plus. I'm going to start at this spot, right, -1, and you can see we get a nice natural triangle right here. Boom, that's good. So that's plus the integral from -1 up to, so -1 in the x, up to 4 in the x direction, f of x dx. And then my last one, I'm going to shade this one, is going to be here from 4 up to 9. And then notice I get another triangle there. So what I'm really doing is looking at this as three different shapes that I'm going to find the area of. And now these are easy area formulas, so shouldn't be too bad at all. Integral here from 4 to 9 of f of x dx. You don't have to rewrite this every time, but note that you can do this with integrals. You can split them up, but notice how this top one matches this bottom, and then this top one matches this bottom, so we're not missing any values within the integral. All right, so let's do this. Let's calculate the area of each one of these. My first square has a 1, 2, 3, 4 width and a 1, 2, 3, 4 height. So it's a 4 by 4. So the area of this one, 4 times 4, which is 16. Right. So I'm going to go ahead and write down here. This one is 16. So area equals 16 plus. My next one, I've got a base here of 1, 2, 3, 4, 5. So my area is going to be 1/2 times 5, and my height is 1, 2, 3, 4. So go ahead and multiply that. We're going to get 10. And then my last triangle here, I've got 1, 2, 3, 4, 5, and 1, 2, 3, 4. 1/2 base times height on that one will be the same result of 10. So what I end up with is 16 plus 10 plus 10. And add those three together, and that will give me my area. That, of course, be 36. This, if you were to attach a units to it, would be just units squared, because these are just units on our coordinate plane. No particular ones in this scenario. So I'm just going to go ahead and just type in 36. You do not need to type in that units squared. All right, let's look at another one. Some of these are more challenging than others. Let me get it clear. Okay, so always make sure that you note from the outset what your interval is using your lower and your upper limits. So I want to start at -2, draw a line, and I want to end at 9. So all the way down here at the end. All right, and then I want to start looking for natural divisions in this. So my first one, really anytime that the slope changes is a good idea to just go ahead and make a division. So here to here, it changes, right? So we got a nice square. And I'm going to go ahead and write this out, -2 up to 0 of f of x dx. Plus my next one here from 0, always got to start with that one, 0 up to 3. It'll be a triangle, right, of f of x dx. Now your next one, I personally think the best way to do this is to go ahead and just divide it here where it changes again and get 2 triangles. I feel like this just makes the most sense, eliminates chances for error. You can try to do the whole thing, but I like to just divide it wherever basically it changes directions here. It's just a good general rule. So that one is going to be from 3 to 6 of f of x dx. And then my last one is going to be from 6 to 9 of f of x dx. All right, let's go ahead and calculate these areas. So I've got my 4 shapes. My first one got a 1, 2 width and a 1, 2, 3, 4, 4 by 2, so that's going to be 8. Here I've got a 1, 2, 3 by 1, 2, 3, 4. So 1/2 base times height there will be 6. That's my area. Next one I've got 1, 2, 3 by 1, 2, 3, 4, 5, 6, I believe. 3 by 6. So that's going to give me 1/2 of 6 is 3 times 3 is 9. And then lastly I've got 1, 2, 3 by 6. So that will also be a 9. Right. So those are my 4 areas. 8 plus 6 plus 9 plus 9. And I believe that gives me 32 units squared. Once you get the hang of this, it really isn't bad. You might make a simple mistake occasionally, but really isn't too bad. All right, let me just go ahead and at least set up one more, and then we'll get to the next one, next section. This one's -7 to 5. So as you divide this one up, -7's here, 5 is here. So just think about your subsections on this one. Now this one might look a little bit more challenging. I think it is because if we look at our shapes, this first one you might think, well, I'm going to go here, here. You could actually do this. This is a trapezoid, so you could actually do the area of a trapezoid, which is 1/2 b1 plus b2 times the height, if you want to do it in that approach. You could also divide this. This is commonly what you'll actually see, is to go ahead and divide that into a square, into a triangle. And then our next one, we've got a rectangle here. And then we finish it with another triangle here, like that. So that we've got 4 areas. And rather than write out all the integrals, let's just do a quick calculation. 1, 2, 3, 4 by 1, 2, 3. So that'd be a 12. This would be 2 by 1, 2, 3, 4. So 1/2, that'd be 4 in that area. And then 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5 by 5 is 25. Here we've got 1, 2, 3 by 5. So that would be 15/2, I believe. So just a quick calculation here would be 12 plus 4 plus 25 plus 15/2. And I think it normally wants these as a decimal. You could probably do a fraction as well, but I'm pretty sure they take decimals with this. So I'll just do a quick calculation if I did this correctly. 48.5 is what I came up with. So again, after you get the hang of this, it really isn't bad. Go ahead and type that in. All right, let's go and look at the next section. It's just level 2. All of these are just different levels. I don't know that they're much harder, except in the next one, level 2, you can have negatives. So go ahead and take a look at this one. And as just a key note here, if this occurs below the axis, if the area is below the x-axis, it is negative. So in this area calculation, we're going to have to take that into account, and we're going to be subtracting any areas that fall below, which you can see we are going to have something there. All right, so let's go ahead and divide this integral up here. We start with 0 and end at 9. So 0 means we're going to draw a line there, and 9 is here. So our first calculation, how I'm going to divide this, my first point here would be at 2, but I'm going to divide this into 2 separate shapes here because we got a rectangle and a triangle, right? So the first integral would be from 0 to 2, just for the sake of saving writing up. I'm not going to write the f of x dx, but should technically be there. So from 0 to 2, and then my next one would be from 2 to 4, right? And I should also do this as well. Since this is below the axis, I'm going to go ahead and write these as negative. So it's a negative since that first one's below the axis, and this one actually should be negative as well because it's below the axis. And then the next one will be a positive, and again, I like to divide it up wherever I see a change there. So plus integral from 4 to 6, and then end with the integral from 6 to 9. So actually breaking this up into 4 different sections. All right, let's go through and do each one of these. The first one is a 2 by 1, 2, 3, 4. 2 by 4, so it's going to be 8. And this is a 1 by 2. So 1/2 of 2 is 1 times 1, so that's just an area of 1. So we got 8, and that's a -8 minus 1. And then our next one, we've got 2 by 1, 2, 3. So that's going to be 3. That's my area there. Actually, sorry, that I think it's 4. Yeah, I wrote too many lines up there. I think it's 4. Yeah, sorry. Yeah, because I think that should be 4 overall. So 1/2 of 2 would be 1, and then times by 4 would be 4. All right, so that's going to be minus as well. So minus 4. And then my next one, this would be a 2 by 1, 2, 3, 4. So that's going to be 4 area, and then we've got a 1, 2, 3 by 4. It's going to be 6. So plus 4 plus 6. Again, I think this green triangle, I can't, for whatever reason, I can't erase just that one part. So I'm hoping that goes down to 4 there. And let's go ahead and add these up. See, these cancel, and we should get negative 3. Did this correct? Boom. All right. So that's correct. All right. So you can see how they divided it up. They did divide that into 3 sections, and they used a different color there to denote they were negative. All right. Let's go ahead and do, maybe let's set up one more. There's my eraser. All right. Next one, from negative 2 to 5. So negative 2 is here. 5 is here. All right. So how this one's going to divide up, again, maybe looks a little bit challenging, but just go to basically all your points where it changes and divide those up. We're going to get a section. Our first section here is a trapezoid, so I'm going to divide it into a square and a triangle. And then we get a rectangle for this one. And then we get a triangle here. Didn't change. Triangle here. And then we get a negative triangle here, and then another negative triangle here. So just remember, if they're below, then you have to subtract them. So if I'm breaking this up, it's going to be from negative 2 to 0, plus 0 to 3, plus 3 to 4, and then minus 4 to 5. And actually, sorry, I don't need this last one. Still, for whatever reason, can't. There's a eraser. I don't need this last one. Sorry, guys. It ends at 5, so I don't need that last one. So just that minus that little one. If we're to go ahead and do those calculations, my first one, I've got a 2 by 1, 2, 3. So it'd be a 6, area of 6. And I got this little triangle up here. That's going to have an area of 1, because 1/2 of 2 times 1. This rectangle in the middle here, I got a 1, 2, 3 by 1, 2, 3, 4. It's going to be 12. Here we've got a 1 by 1, 2, 3. And I kind of messed myself up there again. Hang on. Writing too much here. Let's see where that goes. It actually goes up to 4. Okay. So a 1 by 4. So that's going to be an area of 2. And this last one, I believe, is an area of 2 as well. Yeah. So we get 6 plus 1 for our first one. Then from 0 to 3 is plus 12, and then a plus 2, and then a minus 2. So those will cancel. And I believe we get 19. If all is correct.